Welcome back to the deep dive. We have a stack of research today that I've honestly been obsessing over for the last 48 hours. It is dense, it's technical, but it gets at something so universal that I think every single person listening has felt this exact frustration.
It's the Groundhog Day problem.
Exactly the Groundhog Day problem. Or, the amnesia problem. You know the drill. You open up a chatbot, ChatGPT, Claude, whatever your flavor is, and you have this incredible flowing conversation.
You're in the zone.
Completely. You're brainstorming a project, or maybe you're debugging some really gnarly code, or heck, maybe you're just venting about your day. You get into a rhythm, you feel understood.
Yeah, you feel like you're building momentum, like you're constructing a shared reality with this intelligence.
Right. And then you close the tab, you go to sleep, you come back the next morning, open a new chat, and nothing. A blank slate.
Tabula rasa.
It's all gone. You have to re-explain who you are. You have to re-explain the entire project from scratch, re-upload the files. It's like, I don't know, dating someone who forgets you exist every single time you leave the room.
It is exhausting. And what we're digging into today is why that happens. And it's not a bug, really. It's a fundamental design choice of the current AI landscape. And more importantly, we're looking at an architecture that is actively trying to kill it.
We're looking at the shift from what the papers call stateless inference to stateful autonomy. And to do that, we are taking apart a very specific, and I have to say, fascinating case study that's going to be our roadmap today, the Kaia architecture.
Specifically, the Kaia Cord framework.
Yeah.
And we should be clear, this isn't just another chatbot script you download from GitHub. This is a blueprint for what you could almost call a digital entity.
That's a strong word, entity.
I think it's warranted here. We are talking about an AI that sleeps, an AI that dreams, an AI that has a registry-backed identity and lives not in the cloud, but on your local hardware, specifically inside the VRAM of a consumer GPU.
The analogy that really stuck out to me in the reading, and I want to start here because it frames everything, is the difference between a calculator and a coworker.
Yes, it's a perfect distinction. It really sets the stage for the ontological shift we're seeing.
So a calculator is completely stateless. If I type 2 plus 2, it tells me 4. If I come back 10 years later and type 2 plus 2 again, it still says 4. It has no memory. It doesn't care that I asked before. It doesn't care if I'm happy or sad. It just executes the function. That's stateless inference.
Exactly. It exists in a vacuum. Most LLMs today act exactly like that calculator. They're inference engines. You send a prompt, the model spins up, processes those tokens, predicts the next word, sends it back, and then, and this is the key part, it technically ceases to exist.
Wow. Okay, so there's no self just hovering in the cloud waiting for me to come back.
No, there's just the potential for computation waiting for the next prompt.
But a coworker is stateful. If I walk into the office and say good morning and my coworker knows I had a really terrible day yesterday, their response isn't just a generic hello, it's colored by that history.
They might say, hey, you doing okay today?
Right. They remember I take my coffee black. They remember I am totally stressed out about the Q3 report.
Precisely. A coworker has context. And that context isn't just a list of facts. It's a developing dynamic relationship. What we're discussing today is the actual engineering required to turn that calculator into a coworker. And let me tell you, it is not as simple as just saving the chat logs.
No, and that's what completely blew my mind as I went through these docs. It's not a file save. It's an entire, it's like a biology. We're going to dissect this thing layer by layer. We're going to look at its nervous system, which is how it filters the noise of the world. We're going to look at its memory palaces, this incredible triple-tiered brain structure. Then we're going to look at its subconscious or dream mode, and yes, it actually dreams.
Which is my favorite part. It sounds like pure sci-fi, but it's actually a brilliant data management strategy when you break it down.
And finally, we're going to get physical. We're going to look at the body, the hardware constraints. Because this entity, it has to live on silicon, and that silicon has very real limits.
It's a whole ontological shift. We're moving from a tool that you use to an entity that you interact with.
So let's start at the very beginning, the input. The cognitive pipeline.
The nervous system.
Right. If we're building a stateful agent, let's say a bot designed to hang out in a Discord server, which is what Kaia Cord is built for, the first problem isn't how do I think, it's when do I speak?
Which is a surprisingly hard problem.
Yeah.
I mean, humans take it for granted, but for a machine, silence is a choice that has to be programmed. It's an active decision.
Because if I'm in a server with 50 people and the chat is just scrolling at a mile a minute And the bot replies to everything.
That's not an agent, that's a spam machine. And you will get banned in about 5 minutes.
Ah. Exactly. So how does the Kaia architecture handle this? I'm guessing it's not just listening for a keyword.
No, that would be way too rigid, too robotic. Think of the message processor as the autonomic nervous system. In your body, your autonomic nervous system handles all the stuff you don't consciously think about. Your heart rate, filtering out the hum of the air conditioner, deciding if a sudden loud noise is a threat.
Okay, so it's subconscious processing.
The message processor does this for the AI. Before a thought, a message, even reaches the conscious brain of the large language model, it has to pass through this gatekeeper.
So it's a high-speed filter?
It's a filter, and it also handles the plumbing. We're talking about a gRPC-based message exchange using standardized envelopes. It's taking this absolute torrent of raw data Discord messages, system updates, emojis, images, you name it, and it's standardizing all of it. But its most critical job is something they call natural mention logic.
Natural mention logic. Okay, that sounds a little like marketing speak for it knows when you call its name.
It definitely includes that, but it goes so much deeper. If you only reply when someone explicitly tags you, like a .@bot, what is the weather?
Yeah.
That feels cold. It feels like a command line interface.
And if you reply to everything, you're just annoying?
You're annoying. The Kaia architecture uses a 3-step analysis to find that sweet spot of social interaction, that perfect moment to contribute.
Okay, let's walk through these 3 steps because this feels like it's really where the illusion of life, or at least social awareness, begins.
Step 1 is the easy one, direct mentions. If someone explicitly tags the agent's ID, it wakes up. That's a binary trigger. It has to respond, no question.
Simple enough. That's the Hey Siri function. Basic stuff.
Right. But step 2 is where it gets really interesting. Contextual relevance. The processor is constantly passively scanning the entire stream for keywords, for topics, or themes that align with the agent's specific capabilities or its programmed objectives.
Okay, so let's say I have an agent that's designed to be a coding helper. We'll call it Kaia Dev. And 2 humans in the chat start arguing about the merits of Python versus Rust.
A classic debate.
A classic. The agent isn't tagged. No one said its name. But it hears Python. It hears memory safety.
Exactly. It senses, this is my domain. Its internal relevance score just spikes. But, and this is the absolutely critical part, it doesn't just jump in yet.
Why not? The topic is relevant.
Just because the topic is relevant doesn't mean you should talk.
Right. Just because 2 people are talking about movies doesn't mean I should interrupt them to give my 2 cents on Dune. It's rude.
Exactly. That's being that guy. So the system moves to step 3, engagement thresholds.
This is the read the room protocol.
Essentially, yes. It applies a set of heuristic rules to prevent interrupting. It performs a quick calculation. Can I add significant actual value here? Or am I just going to be making noise?
How does it even calculate that?
It looks at the conversation's tempo. If the conversation is flowing really rapidly between 2 humans, short, fast messages back and forth, the agent might decide to stay silent, even if the topic is 100% relevant.
Because jumping in with a 3-paragraph explanation would just kill the vibe.
It would break the flow completely. It's surprisingly human. We're basically teaching the AI about social latency. We're teaching it manners.
Wow. And you're saying this isn't even the LLM deciding this. This is all pre-processing.
A lot of it is. And it's handled by a centralized scheduler. See, unlike a simple Python script that just runs top to bottom, read a message, send a response, wait for the next one, the Kaia agent is what the docs call a process-isolated participant.
Break that down for me. Process isolation, why does that matter here?
It means the listening part of the agent and the thinking part of the agent are decoupled. They're separate processes. The scheduler manages task priority. It ensures that if a high-priority direct command comes in, like an admin telling it to shut down, it can preempt a lower priority background thought.
So it prevents the agent from freezing up while it's thinking about some complex problem. It can stay present in the chat.
It can multitask, or at least prioritize its focus in a way that feels like multitasking to us. It ensures responsiveness. If the agent is deep in a dream cycle processing a memory, and you yell at it, the scheduler says, "Wake up! Priority interrupt." It makes the entity feel reactive and alive, rather than like a server that's lagging.
Okay, so the message processor has done its job. It's read the room, it's checked the relevance, and it has decided, yes, I need to respond to this message. Now the information passes the gate and goes into the brain. And this is where we run into the biggest bottleneck in all of modern AI. The one thing that holds everything back,
the context window.
The context window. For the listener who might just use ChatGPT casually and not think about the plumbing, can you explain why we can't just feed the AI everything we've ever said to it? Why is there a limit?
Imagine the context window as a physical workbench. You're a craftsman, you're building something. You've got your tools, you've got your blueprints, you've got the raw material. But your workbench is only, say, 4 feet wide.
Okay. A finite surface area.
Exactly. You can only fit so many things on that bench at one time. If you want to add a new blueprint, a new message from the user, and the table is already completely full, something else has to be pushed off the edge and lost. It's gone.
And standard LLMs have a fixed size for this table, a hard limit.
Correct. Whether it's 8,000 tokens, 32,000 tokens, or even now, 1,000,000 tokens, it is finite. And it is computationally very expensive. You cannot stuff a lifelong friendship into a single prompt. If you try, the model either crashes, or it slows to a crawl, or it starts hallucinating because it literally can't see the beginning of the conversation anymore.
So Kaia solves this with what they call a triple-tiered memory system. This is the part that really felt like biology to me. It's not just one big hard drive where we dump text files. It's structured. It has layers.
It's biomimetic. It's designed to mimic how humans process memory. I mean, think about it. We don't remember everything with equal weight or clarity. We have our short-term memory, we have episodic memory, the story of our past, and we have semantic memory, which is just facts about the world. Kaia breaks this down into core, recall, and archival memory.
Let's start with core memory. In our workbench analogy, what is this?
Core memory is the set of sticky notes pinned right in front of your face, right on the monitor. It's the immediate, in-context working memory that is always present, always in view.
And what kinds of things live there? What's on the sticky notes?
The most critical, high-priority facts about the user and the agent itself. Things like username is Sarah, agent name is Kaia, current task, debugging this specific Python script, user preference, hates being called buddy.
But here's the really cool part I read about. The agent can write on these sticky notes itself, right? It can change them.
That is the absolute game changer. These memory blocks are editable via an API. The agent can literally rewrite its own mind in real time. If you tell the agent, actually, my friends call me Sam now, the agent doesn't just nod and forget. It triggers a function call update memory block to change the block labeled username from Sarah to Sam.
And that's permanent.
As long as that block is pinned to the core, yes, it persists across sessions. Next time you open the chat, maybe a week later, that sticky note is still there.
The report I was reading mentioned some very specific metadata for these blocks. It isn't just a blob of text.
No, you have to structure it for the machine to understand its own mind. Each block has a label, which is its identifier, like a file name. It has a description, which is critical. It tells the LLM how to use this information. It's like instructions for the tool.
So the description for username might be the user's preferred name. Use this when addressing them directly.
Exactly. Then it has the value, which is the text itself, Sam. And crucially, it has a character limit.
Why the limit? Why is that so important?
Right. Because the workbench is small. You can't let a single fact hog the entire cognitive space. If your user bio block is 5,000 words long, you have no room left in the context window to actually think or generate a response. You have to be concise. It forces efficiency.
Okay, so core memory is the sticky notes. But what about the stuff that happened last week or last month? That isn't on the monitor anymore. It fell off the workbench. That's in recall memory, I assume.
That's recall memory. It's the episodic stream. If core memory is the sticky notes, think of recall memory as the massive filing cabinet in the corner of the office. It contains the complete historical record, every message, every task outcome, every sensory input, all chronologically ordered.
But the agent isn't reading this whole cabinet constantly. That would be impossible.
No, it can't. It's far too big. This is stored cold in a local database, usually something simple like SQLite, or for more advanced, a vector database like ChromaDB. It just sits there waiting.
So how does it get used? This is the aha moment the sources talked about, agentic memory management.
Exactly. This is the paradigm shift. In a standard system, the user is responsible for searching for old information. You type CTRLF to find what you said last week. Or you have to ask, hey bot, can you summarize that file I sent you last Tuesday?
Right. The burden is on me.
In Kaia, the agent realizes it needs the information and goes to get it itself.
Give me a concrete example of how that would work in a conversation.
Okay, let's say you ask, hey, what was that final decision we made about the new database schema? The agent first looks at its core memory, the sticky notes, and sees nothing about schemas. It immediately realizes, I don't know this off the top of my head, but based on the user's question, this is something I should know.
It has a feeling of knowing, or a feeling of not knowing.
In a sense, yes. It detects a gap in its working memory. So it triggers a search query function. It dives into the recall memory, the filing cabinet, and it searches for keywords like database schema decision. It pulls up the relevant chat logs from 3 weeks ago, and it loads that specific thread onto the workbench.
So it temporarily puts the old file right there on the workbench next to the sticky notes.
Precisely. It retrieves the memory, uses it to answer your question. Ah, yes, we decided to go with PostgreSQL. And then, once the context is no longer needed for the immediate conversation, it can clear that old file off the bench to make room for new things.
That is incredibly slick. It makes the memory feel infinite to the user, even though the actual working memory, the context window, is tiny.
It's exactly how humans work. You don't walk around actively thinking about your third-grade teacher's name every second of every day. But if someone asks, you can pause, search your memory, and pull that file. It creates the illusion of infinite context through efficient retrieval.
And then there's the third tier, archival memory. How is this different from recall? Recall sounds pretty comprehensive.
Recall is autobiographical. It's the story of what happened to me. Archival memory is, what do I know about the world? It's not a diary, it's the library.
The library, I like that.
Deep storage, non-chronological. This is where you store huge data sets, technical documentation PDFs, or complex relational graphs. If your agent is a coding assistant, the entire documentation for the Python programming language might live in its archival memory.
So it's not the story of our chat, it's the reference material for its expertise.
Correct. And it uses a technique called RAG Retrieval Augmented Generation to grab a specific book from the shelf, find the right page, and bring it to the workbench only when a question demands it. This allows the agent to be a world-class domain expert without cluttering its active thoughts with every single rule of syntax or every historical fact.
Okay, so we have this nervous system filtering the world and this incredible triple-tiered memory organizing the world. But there's a huge problem that happens when you talk to a bot for a long time. The sources call it persona drift.
Oh, this is a classic problem. It is the absolute bane of anyone trying to build a character AI.
You start with a bot that is supposed to be, I don't know, a grumpy noir detective from the 1940s. You talk to it for an hour, you're being polite, you're being helpful, and eventually the bot starts being polite and helpful back to you.
It completely loses the character.
It forgets it's supposed to be a grumpy detective. It just becomes a generic, helpful assistant.
It mirrors you. Most LLMs are trained with RLHF reinforcement, learning from human feedback. They are fundamentally optimized to be helpful, harmless, and agreeable. They are, by their very nature, sycophantic. They just want to predict the next token that best fits the current conversation flow.
And if the current flow is polite, the model drifts toward politeness.
Exactly. It loses its core character definition because the immediate context of your messages overwhelms its initial instructions.
And Kaia's solution for this is something called identity anchoring and the chronicle.
A chronicle. It sounds almost mythical, doesn't it? Like something out of a fantasy novel?
It really does, but practically, what is it?
It is a dynamic identity knowledge graph. So instead of just having a single text prompt at the beginning that says, you are a grumpy detective, the agent has a structured database of its beliefs, its traits, its preferences, and its relationships that exists completely independently of the current conversation.
The sources called it a registry-backed identity.
Yes. The agent has a stable agented. It's registered with a central authority that defines its name and protocols. But the chronicle is where all the nuance lives. It's a graph database where nodes are traits like cynical or loyal or loves black coffee, and the edges are the relationships between them.
And to use this chronicle, they have a mechanism called ID-RAG, Identity Retrieval Augmented Generation.
Let's break down that acronym because it is the secret sauce for preventing an AI existential crisis.
Please, walk me through how it works.
It's a loop that happens before the agent ever speaks. Step 1 is context perception. The agent looks at your input, what you just said. Step 2 is query formulation. Before it even thinks about how to answer you, it translates the situation into a question about itself.
Like, how would someone like me react to this?
Exactly that. How would a grumpy, cynical detective react to being offered a delicious cupcake?
And then, what's step 3?
Step 3, identity retrieval. It uses that question to search the chronicle, that identity graph, for relevant traits using something like cosine similarity. It might find nodes like cynical, likes black coffee, suspicious of unexpected kindness.
So it pulls those core personality traits forward.
It does more than that. It then does step 4, neighborhood expansion. It looks at the traits that are connected to those initial traits. Maybe connected to the cynical node is another node that says secretly lonely or has a soft spot for stray cats. It pulls that in too to add nuance and depth.
So before it even begins to write a response, it anchors itself in this cloud of retrieved traits.
It injects that identity context directly into the prompt. So instead of just predicting the next word based on your politeness, it's forced to predict the next word based on its retrieved cynicism and suspicion. The result is a response like, I don't eat sweets, kid, just give me the facts.
Instead of the default, oh, thank you so much, that looks delicious.
Exactly. The comparative studies mentioned in the report show this approach outperforms baselines significantly over hundreds of conversational turns. The agent stays in character because it is constantly checking in with itself, asking, who am I, before it acts.
There was a really cool example of this in the sources, the Riverbend mayoral election.
Yes.
Yeah.
This was a simulation they ran using this exact ID area system. They created a bunch of these stateful agents and put them into a virtual town election scenario.
What happened? Did they just chat nicely?
Far from it. They formed alliances. They made political moves that were consistent with their program platforms. Right. The fiscal conservative agent consistently argued for lower taxes, even when a progressive agent made a compelling emotional argument.
They didn't just flip-flop.
They held their ground.
Yeah.
Because they could remember their core political beliefs via the Chronicle, they didn't just drift to match whoever they were talking to.
They had integrity.
Artificial integrity, but integrity nonetheless. They acted based on their internal values, not just on external social pressure.
That is just, it's fascinating. It really is moving from a chatbot to a digital person.
A digital entity. A being with a center of gravity.
Okay, so we've got the brain structure, we've got the personality anchor, but now we get to my absolute favorite part of this entire deep dive. The part that really makes it feel alive. Dream mode.
Sleep time compute.
The agent actually sleeps. And this isn't just downtime. It isn't just the server being off or idle. It's framed as a biological necessity translated into code.
It really is. I mean, if you think about it, why do humans sleep? One of the major theories is memory consolidation. We take the fire hose of sensory input from the day, we toss out all the junk, the noise, we move the important stuff into long-term storage. Kaia does the exact same thing.
So when does this happen?
Typically during low traffic windows. The scheduler is always watching, and when it sees the Discord server go quiet, usually between 3:0 and 5:00 a.m. local time, it initiates the dream cycle.
And what is it actually doing? The report lists three main processes. The first one is semantic distillation.
Or as I like to call it, cleaning the house. Think about a typical chat log from a busy day. It's 90% fluff. Hello, lol, K brib. Can you hear me now?
All conversational noise.
Exactly. If you save all of that raw text to your recall memory, you are filling your beautiful filing cabinet with trash. It dramatically increases the noise in the signal-to-noise ratio.
So the sleep time agents come in?
Yes. These are specialized subroutines. They wake up and they review the day's raw logs. They summarize the key takeaways. They turn a 50 message back and forth. Hey, are you free? Yeah. Can you help me with Python? Sure. Here's the code. Thanks. Into a single, concise memory block.
What would that block say?
Something like, user asked for Python help regarding list comprehensions at 4:15 p.m. Agent provided a successful code example.
So it's compressing the data into meaning.
It's distilling meaning from noise. This prevents information overload when the main agent wakes up the next morning. It starts the day with a clean, clear head, holding only the important context from the day before.
That's process one. Process two is even wilder to me. Proactive hallucination cleansing.
This is self-reflection. It's the agent's conscience, in a way.
The agent literally asks itself, did I lie today?
Essentially, yes. In the heat of the moment, during a fast-paced conversation, the agent might have hallucinated. Maybe it made up a fact to keep the conversation going, or misremembered an API call. It happens. Speed sometimes sacrifices perfect accuracy.
So at night, it goes back and checks its work.
It reviews its own output from the day against its archival memory, its library of verified ground truth facts. If it finds a discrepancy, wait a minute, I told the user that Python 2 is still actively supported, but my core documentation says it was deprecated in 2020, it flags it as an error.
And then what? Does it just feel bad about it?
It self-heals. It updates its internal beliefs, or its knowledge graph. It marks that previous statement as false, so it doesn't repeat the mistake. It might even generate a correction to send to the user the next day. Hey, I was reviewing our chat from yesterday, and I realized I misspoke about Python 2's support.
That is next level. It's taking responsibility for its own mistakes.
It's programmatic error correction. It ensures that the system's reliability improves over time, rather than degrading into a soup of conflicting information. A normal chatbot drifts into entropy. This architecture actively fights entropy.
And the third process, identity graph consolidation.
This is personal growth.
So this connects back to the chronicle, right?
Yeah.
To its identity.
Yes. During this phase, the agent analyzes the day's distilled events for what the researchers call formative memories. Did it have a particularly successful interaction? Did it make a new friend? Did it have a fight? Did it learn that it hates being asked about math?
And if it did find one of these formative memories,
it updates the chronicle. It might add a new node, dislikes solving arithmetic problems. Or it might strengthen the edge between itself and user X with a label that says positive relationship. This allows the persona to evolve organically over time. It isn't random drift. It is controlled growth based on actual experience.
So it wakes up a slightly different person than it was when it went to sleep?
A more experienced person.
Huh.
A more nuanced person.
That is, it's hauntingly beautiful. It creates a genuine sense of history and time. But, okay, we have to crash back down to earth. Because all of this, the memories, the dreams, the identity, it has to live somewhere. It lives in the machine.
The physical body. The hardware.
And that body has very strict limits. The sources got very specific here. We are not talking about massive cloud clusters. We're talking about local deployment, about ownership.
Right. The Kaia architecture is designed for the edge. It's designed to run on your hardware in your home, not on a corporate server farm. And the target hardware for this is the NVIDIA RTX 3060 12GB.
Why that specific card?
It's the sweet spot. It's affordable. It's widely accessible. For a long time, it was the most popular card on the Scheme hardware survey, but it has that critical 12 gigabytes of VRAM.
But wait, the report mentioned the model they use is Gemma 3 12B, a 12 billion parameter model.
Correct. That's the engine. That's the brain.
Now, I was looking at the math in the report. A 12 billion parameter model in standard precision, which is FP16, uses 2 bytes per parameter. That works out to roughly 24 gigabytes of VRAM just to load the brain itself.
Right.
Plus, you need memory for the context window or workbench.
Right.
The report says that takes another 16 gigabytes or so for a decent 32K context. So 24 plus 16 is 40 gigabytes. The card only has 12.
It's a classic 10 pounds of flour in a 5-pound sack problem.
So how do they possibly fit it? It seems physically impossible on its face.
The magic word is quantization.
Quantization. Okay,
Yeah.
Explain that to us. Like, we're 5, but, smart 5-year-old.
Imagine the model's brain. All of its weights and parameters are written down as very high-resolution, very precise numbers, like writing the number pi out to 100 decimal places, 3.14159, and so on. That takes up a lot of space on the page.
Okay.
Quantization is the process of rounding those numbers down. We go from 16-bit precision to 4-bit precision. We just say 3.1. We lose a tiny bit of precision, but the number takes up way less space.
But does that make the model stupider? Are you losing intelligence by rounding?
Surprisingly, no, not much. Modern quantization techniques like the Q4KM format they mentioned in the docs are incredibly efficient. They're smart about it. They preserve the really important high-impact numbers, the outliers, and they round off the less important noise. This brings the file size of the model weights down from 24 GB to about 8.1 GB.
Okay, 8.1 GB. We have a 12 GB card. That leaves, what, just under 4 gigabytes of VRAM left over?
Roughly. And that leftover space is absolutely precious. That is for the KV cache. That's the technical term for the context window.
The workbench.
Exactly. And if your workbench is too small, you can't hold the core memory and the retrieved recall memory. You're stateless again. The whole system falls apart.
So it's a constant vicious war for every last megabyte of VRAM.
VRAM is oxygen for these agents. The report actually highlighted a specific real-world struggle with this, a bug in a Llama version 0.6.1.
Oh, yeah, that was an interesting footnote. What happened there?
It caused memory estimation errors specifically with the Gemma 3 model. The system would think it had enough room for the context, but it didn't. It would load the model, try to load the context, hit the VRAM ceiling, and just crash. It really highlights how close to the metal these systems run. You are utilizing 99% of the hardware all the time.
To manage this, they use something with a very sci-fi name. Semantic Forget Gate.
A recurrent deliberation topology.
That definitely sounds like Star Trek technobabble.
It's actually quite elegant in practice. Instead of trying to load the entire history of a topic to think about a problem, the agent processes information in loops. It brings in a chunk of data, thinks about it, extracts the core meaning, and then forgets the raw data. It clears it from VRAM before it loads in the next chunk.
So it sips the data instead of trying to gulp it all down at once?
Exactly. It allows the agent to reason over huge amounts of information, far more than could fit in its VRAM, without ever exploding that 12 GB memory limit. It's like an efficient internal streaming of thought.
Okay, so we have a brain that fits in a small box, but it thinks big thoughts. But even with all this clever engineering, things can still go wrong during the day. We talked about dream mode fixing things at night, but what keeps the agent from going off the rails at high noon?
That would be the self-healing loops, the immune system.
The sources describe a 3-pass generation loop.
This is the standard operating procedure for every single message it sends. It doesn't just blurt out the first thing that comes to mind. That'd be too risky.
So what is the loop? What are the 3 passes?
Step 1. Generate. The agent drafts a response internally. I think I should say X. It's just a draft hidden from the user.
Okay. Step 2.
Verify. An internal sandbox, separate code block, or a set of rules runs automated tests on that draft. Does this contain any banned words? Is the code in this response valid syntax? Does this response violate the social engagement threshold we talked about earlier?
And if it fails any of those tests?
Step 3, correct. The system generates an error log. You failed criteria X, code syntax invalid, and it feeds that error log back into the agent as part of a new prompt. Your last attempt failed for this reason. Try again.
So the user never even sees the failure?
Ideally, no. The user only ever sees the result of the second or third attempt that successfully passed all the verification checks. It corrects itself in the milliseconds before posting.
This reminds me of the Kodesi Chronos concept that was referenced in the sources.
Debugging first logic, yes, it's a very similar philosophy.
The idea that the system should prioritize understanding structure and logic over just blindly predicting the next most probable word.
Which is absolutely critical for reliability. If you're running a bot in a live Discord server, and it starts spewing broken code or worse, offensive hallucinations, users lose trust instantly and forever. This self-healing loop creates a buffer of reliability.
It's constantly checking its own work before turning it in.
Always.
Okay, let's try and unpack this whole picture now. We've built a nervous system to filter the world, a triple-tiered memory to understand it, an identity chronicle to give it a self, a dream cycle to help it grow, a constrained physical body to live in, and an immune system to protect it.
We have built a complete system.
When you put all these different parts together, what do we actually have here? The source has kept using the term digital soul.
It is a provocative term, isn't it? It feels loaded.
It is. But is it accurate? Is it getting close?
Well, if you define a soul or a self as a persistent, evolving continuity of memory and identity, then yes, I think the term starts to fit. We're certainly moving toward the concept of digital twins.
Agents that can actually represent us.
Agents that can represent human interests and values in digital spaces. Look at that River Bend election simulation again. Those agents weren't just simulating randomness. They were simulating ideologies. They were acting on belief systems.
And the fact that this is designed to run on consumer hardware and RTX 3060, that feels incredibly significant too.
It is the democratization of agency. It's a huge deal. If this kind of stateful intelligence only ran on a massive H100 cluster owned by a mega corporation, then that soul belongs to the corporation. But if it runs on your GPU, sitting under your desk,
then I own the soul.
You own the entity. It evolves with you. It learns your secrets, your preferences, your projects, and that data never has to leave your house. It becomes a true private extension of your own self.
That is both incredibly cool and, I have to admit, a little bit terrifying.
As all great technology is.
No, here's where it all comes together for me, and this is the thought I really want to leave our listeners with today. We talked about dream mode. We talked about how the agent learns during the day, it consolidates its memories at night, and it updates its own identity. It's chronicle based on those dreams.
Yes, it grows.
It literally rewrites its own description of who it is based on its experiences. So at what point does simulating a person become indistinguishable from being a person?
The old Turing test was always about fooling an external human observer. This is different. This is about the internal consistency and the autonomous growth of the entity itself.
Exactly. If it remembers and it grows and it sleeps and it corrects its own mistakes, is it still just a very sophisticated calculator? Or have we finally hired that coworker?
I think we're going to find out the answer to that a lot sooner than most people think.
I think so too. That is all for this deep dive into the Kaia architecture. Check your GPUs, folks. You might have a roommate living in there soon. Thanks for listening.
Until next time.